Hello, everyone, and welcome to today's presentation, Interoperable Physical Asset Data Management and Digital Twins Using Knowledge Graphs. With us today, we have speakers from both Taxonic and Top Quadrant. Established in 2001, Top Quadrant offers the market's most complete and mature information governance solution based on knowledge graphs. Taxonic, founded in 2012, is a Dutch consultancy specializing in knowledge engineering and is also a reseller and implementation partner for Top Quadrant. I'd like to introduce you to our speakers today. First of all, we have Eliana Papusoglu. Eliana is a linked data consultant with Taxonic. We have Jan Voskul, who is an ontologist and CEO for Taxonic. And we also have David Price, a senior solutions architect with Top Quadrant. Before we get started, let's review a few logistical items. Please feel free to ask questions as you go along by using your GoToWebinar controls. To post questions, please look on the right-hand side control panel. You should see a drop-down box for questions. If you click on the box, you should be able to post your question at any time during the presentation. We will address as many of those questions as time allows at the conclusion of the webinar. We will also be recording today's webinar and we'll send a link to the recorded version as well as to the slides. And with that, I'll hand it over to Jan to get us started. Jan?
Thank you, Christy. So the agenda for today consists of 3 parts. We start with an introduction about rethinking asset information management. Then we go over to a demo in which we show how information can seamlessly be exchanged in construction projects. And finally, we will have some attention to evolving usage and innovative usage scenarios. So let me begin with an introduction. In the construction world, we are going through a transition. We're going from documents to data. It's a datafication process that we're all dealing with. Documents still rule though. Large infra projects still use up to 10 million documents. Documents involve manual processes. Computers offer tremendous potential, but this involves a move towards data because computers understand data and not text. And when we have made this move to data and data is ruling and we have more data than documents, then a lot of new possibilities will be available for everyone. So when we have all this data available, then each object in a construction project will have a digital twin. We can reuse the information across life cycle stages of each of the assets. We can optimize processes also across the entire life cycle of these assets. Information can be exchanged seamlessly. And all this will make new usage scenarios possible. For instance, predictive maintenance is something that everybody is talking about, but think also about constraint optimization, where you can, create big savings by optimizing planning procedures. So digital twins are not optional, at least not when you want to stay ahead of the competition. But datafication is easier said than done. Many datafication projects turn out to become a black hole, really. So a lot of effort and resources going in, but not so many results coming out. And that's because data without a data model are simply unusable. And while it is easy to exchange data, exchanging data models is very difficult because data models are very often hard-coded in applications and databases. So what we need is knowledge graphs. Knowledge graphs represent data and data models alongside each other in a unified format. And this format is RDF. That's what really underlies all information exchange using knowledge graphs. Data models are very important because data models provide the semantics so that computers can understand and work with the data. A semantic model consists of what we call a semantic triangle. You need 3 things. You need a class hierarchy and inheritance along that hierarchy. You need naming and definitions, and you need constraints. Now here you see how a semantic data model looks like in practice. So here we are looking at top-rate Edge, the enterprise data governance solution that Top Quadrant has created. And here you see the three ingredients. So you see the class hierarchy with inheritance, you see the constraints, and you see the naming. Let us zoom in a little bit on these things. So the class hierarchy contains classes that are defined externally in all kinds of standards. Those are the light yellow circles. And of course, we also create our own classes when we create a semantic data model. And these are the darker yellow classes. Now, when it comes to naming and definition and description, this is usually text, but because it's highly structured, we can do interesting things with these things also, as we will show in the demo. Finally, we need rules and constraints that say that, for instance, an installation site is a physical object, or that a manufacturer is a string and a date of installation is a date. These constraints are very important to maintain data integrity, but also to do interesting things with these data. When it comes to using semantic data models to exchange data better, it's very much a game played by asset owners nowadays. So the principals, the asset owners, for them, it's easy to say to all their contractors that are working on projects that create these assets for them, well, to make it part of the contract that the contractor delivers data in a certain format that is according to the semantic data model that the principal has provided. And these semantic data models in practice are often called an object type library or an engineering class library or a reference data library. In the semantic web world, we call this a ontology. And there are many examples of projects that do this. Top Quadrant and Taxonic have jointly been involved in a project at Schiphol Airport. Schiphol Airport is one of the 10 or 15 largest airports in the world, in the Netherlands. And there we did an asset information management project with these semantic data models. Now, when you look at this whole thing from a contractor's perspective, the world looks differently, because as a contractor, you're going to be forced by many different customers that you use their OTL. And that may be a problem, because as a contractor, you have a lot of backend IT systems. And do you have to reformat these? Do you have to do the integrations each time from scratch? Well, the answer is no. So what we're going to do is to show you an example with a fictitious construction company and a fictitious customer. So we have Conco, the construction company, and we've got Gridco, the customer, a grid operator. And we're going to build a substation for Gridco. So what we have is we have our own standardized OTL, standardized in the sense that we, within Conco, we use this in all our projects. And we map this to the OTL that Gridco uses. And the result of that mapping is just another graph, a larger graph. Now, how is this mapping done? Well, here you see how top-rate Edge supports this. In this column, you see the Conco classes. They are mapped to the Gridco classes in this column. And here on the right, you see automatically generated suggestions that we can use. Now, how are these mappings generated? Well, basically, it has to do with the similarity of the labels. So you got one label in one OTL and another label in another, and when they're very similar, it's probably going to be the same thing. So by adding more and more labels to your OTL, you will make it possible to match more. You will find more matches, but also more false positives. And that's, of course, something that you want to avoid. A development that's very promising is the use of third-party taxonomies. So some examples are a Dutch standard CBNL or an international standard like CFAS. These standards provide thousands and thousands of object classes. Now, if we at Conco, we have our OTL and we map the class door to the notion of door in that external ontology, and Gridco does the same thing, then we can derive the mapping using simple inferencing rules. And that's happening more and more nowadays. Ultimately, though, what we offer is not so much a tool. It's, of course, a tool is very important, but it's more about the approach. It's more a standardized working process. So whenever we at Conco start a new project, we follow a number of simple steps, and then we can start and integrations will be done. And in this work process, well, we start with what we call a project OTL. And this project OTL is really a combination of a selection of the stuff that's in our own Conco OTL. Well, we combine this with the OTL we get from the customer, in this case Gridco, plus the mappings. So three things: our own OTL, the customer's OTL, plus mapping. And that whole thing, that whole set of graph elements, that's going to be the project OTL. And that's going to be the data model for the project database. Often we call the project database a configuration management database, a CMDB, but let's call it project database for now. And what you see under 3 is that, well, there are many different backend systems, IT systems that we at Conco use, and they are connected, integrated with the project database. And all these integrations will remain intact from project to project because the Conco OTL is the structuring principle there. So the requirement is reusable from project to project. And once we fill the project database with objects, and these come usually from these backend systems, then at some point the database is complete and we can generate a data delivery from it. And what we use there is the mappings, and also from project to project we can reuse a lot of the generation logic. It's really very generic stuff, and occasionally you might run into a mapping that needs some extra attention, but usually you can reuse these things. Well, a question that many people have is, does this scale? All very nice knowledge graph technology, but what if you have billions and billions of objects, which can easily happen if you have a larger project? Well, the answer to this is graph coalescence, more specifically a whole family of solutions called graph federation. And what we basically do is we partition the data in different databases and we coalesce them into one overall view. So from the standpoint of the outside world, it's just one database, but in reality, it's multiple databases. Of course, it's not trivial to do these things. Certain queries might degrade in performance. Those things are things you really need to take into account when designing the partition. But the bottom line is that scalability is another problem. And with this, I'm handing it over.
Thank you, Jan. So what I'm going to demo here is graph coalescence that Jan talked about as a tool to observe a single data set from 2 different perspectives. One being the perspective of a first-party OTL that you have as a contractor, and the second one being a perspective through the OTL of a customer. So this is our platform that we are using, the top right edge. And the main part of the screen shows recent developments, what has been edited, what you've recently viewed. But what I want to focus on is this left part. So on Edge, information is organized into asset collections, and you have different types of these asset collections. There are more types than what you see here, but these are the ones that we'll be using. So taxonomies, data graphs, ontologies, crosswalks. And let's jump into it right away. We will look at the two OTLs first. And we will start with the contractor perspective, Conco. And to repeat what Jan said, here we see the class hierarchy on the left. Part of this has been built on existing standards like UUDT, which is a semantic standard for quantities, units, dimensions, and types. And of course, standard reuse is always good. But part of it is, of course, specific to our OTL as the contractor. I am going to delve deeper into this. Let's look at physical objects. And as I go here, you can see the hierarchy expanding. And let's just take one of these as an example. Let's look at something simple, a door. What is the first at the top is general information, so labels and types. And then as I scroll down, more specific things pop up. You can have definitions and descriptions, maybe pictures that are representative of this type of asset that you're looking at. And then you have the properties or the restrictions that instances of this object should fulfill. So here I have, for example, specifically for my door, the door leaf filler material, leaf material thickness type, etc. And each of these have a type. And I would like to highlight how some are integers, some are plain strings, but some can be concepts. For example, this door type may be something that you want to give more concrete recommendations for. This is where taxonomies come in. So let's pop on over to taxonomies to see what this is about. Here we have the Conco taxonomy, which is based on GWSW, which is a Dutch standard for urban water management. And what we see here is a series of concepts. One of them is door type. And if I expand it, I see that there are different types, as you might expect: inside door, outside door, rotating door, transport door. You can provide these as guidance to people that seek to describe what kind of door they have. Or you might set a constraint that each door that exists should be one of these types. It's entirely up to you. And back to the contractor OTL, we talked about properties specific to the door. You can also have, as Jan said, inherited properties that are general to all components, so the parent class. And well, there's nothing really special here. You see properties to describe dates, IDs, manufacturers, that kind of thing. And let's look at the OTL for the customer, so the grid operator in this case. I am going to go back to ontologies and select the GridGo OTL schema. And what pops up should be familiar. You have a same kind of hierarchy. Let's look at the physical objects again, this time with a different subclass, actual object. And I can go deeper and deeper, but let's just search for the door that we saw previously. Here it is. This view is less detailed, but again, you have generic attributes followed by the properties. And a lot of these look the same as they did last time, but there are subtle differences. There is a lot of assets here, and I'm not going to go into much more detail, but let's just take a look at a different one to have some variety. I want to look at a data cable. So this is a data cable, and the reason I am highlighting this one is because, well, a cable is supposed to connect things. And to describe this in the OTL, you can have properties that point to other instances of objects. So in this case, we have a cable that has a connects property, and it is supposed to point to instances of component systems, which is one of the parent classes. So you can do that as well. So we have seen the two OTLs, the contractors and the customers. And let's look at the data graph next. We want Conco CMDB for this one. The CMDB is essentially the project database from the contractor's perspective. And here we see a list of instances for some of the classes that we saw. I can grab the door again to make things easy. And indeed, as we expected, we see the attributes that we saw in the OTL, but this time with specific values. So this specific door has this item ID, serial number. It is indeed of type door, and it has this information about its provenance. Again, there are a lot of properties here. And let's also look at the data cable. Same idea, general properties, more concrete properties, etc. What we also observe here is one more link to a different graph. For product info, we have this one, Hyperdata 6000 something. And if I click onto show details here, I will see more information about this cable model pop up. So it's no longer about the specific cable necessarily, but about the type of cable that we have in this instance that the manufacturer produces. You can do this as well. All of this information resides in a different graph, but it is referred to here. And something else that might also be of interest is the fact that we have buildings here. And when you have buildings, you may also be interested in their physical location in the world. And Edge can help you visualize this. So if I go to panels here and I click on the Map Explorer, we will see a map view pop up. And I have added 2 icons for substations here, each at a specific GPS coordinates. And we also have some geometries to point out some buildings. Okay, so this is the data from the contractor's perspective. And by the way, you can also customize this view by selecting different columns to add on this list. If you want to see the IDs, you can do that, or maybe the types as well. And notice that under types, you have one type for all of these instances, which is to be expected because each of these indeed only has one type assigned. It is a Conco building, end of story. So to go back to our question, how do we bridge these two perspectives? And the answer is crosswalks. So let's look at crosswalks. When you create a crosswalk, you're given the option to choose what you want to bridge. So we have selected the 2 OTLs in this case. I have created this ahead of time. And you should also choose what kind of ontological entity you want to bridge. In this case, we are bridging classes. And this is why on the left side, you see classes that are present in Conco, the contractor OTL. The right side is empty, for the top part at least, but near the bottom, I have pre-added some mappings already. So I've mapped cabinet to cabinet, capacitor system to capacitor system. Note the capitalization here. On the left, we have the first letter as a capital because it comes from the Conco OTL. On the right, we have the first letter be lowercase because it comes from the Gridco OTL. That's one way to remember the difference here. And you might notice that all of these class labels look the same or almost the same and wonder, well, is there any way I can simplify this? And the answer is yes. So crosswalks can be created as a combination of semi-automatic mappings with a human in the loop to approve or reject them, and manual mappings where you can go in with your knowledge of the domain and pick which assets line up. For the semi-automated part, I can click on Generate Mappings here. And on the right, I will see a list of the suggestions that Edge has generated for me. For the most part, they can be trivial. For example, I have a information object here, and the suggestion is map to information object from the other OTL. Okay, that makes sense, I guess. And under this, I see also the suggestion to map to information processing object, which may sound similar enough, but it's a different thing. So between these two, I can suggest one mapping to apply and one to not apply. And this should show up in my list here. So I selected apply, and here it is. In other cases, you may know that the labels don't match exactly. For example, we have a Buchholz relay here on the left side from the Congo OTL. And the suggestion is to map it to either voltage relay or plane relay. I'm going to accept the plane relay one. And if we look at it, if I scroll down to find the Buchholz relay again, here it is. You may wonder why this mapping was generated so easily. If I look at the details of it, I can see that relay has alternative labels. And this is also taken into account when these suggestions are generated. In cases where the label does not match, you can do your own thing entirely. For example, I know that we have this building class and there is no good suggestion for it. But based on my knowledge of the customer OTL, I have seen that an equivalent class exists and it's called housing system. So if I start typing here, housing, yes, here it is, it pops up. I can select it and I can add it as a match. And here it is. So this is the story about creating these matches. This crosswalk was about classes, and I have also prepared one for properties because these also need to be mapped. I am not going to go into it right now, but the logic is the same. You generate suggestions, you accept some, you add matches that the automated suggestions did not get, and then you're on your merry way. So what does this mean? How can I use this? If I go back to ontologies, I have created a new one based on the grid co OTL and on the Congo OTL and on the two crosswalks that we've created. And I'm going to go into it. Same hierarchy. This one is based on the grid co OTL, which is why it's a little short. And if I go here into physical object, I can see the two child classes, one from the grid co OTL and one from the Congo OTL. And I want to find a class that we mapped. I'll go to door. And you can observe here that we have indeed a crosswalk match mentioned. Let's also look at the grid co side. Let's look at the door there. And the thing I want to point out is that in the properties, you see some duplicates. And that's because these are generated based on the crosswalks that we have. So the way this works is based on shackle shapes, shackle being part of the knowledge graph standards supported by W3C for modeling and validating data. And new shackle shapes are generated based on the crosswalks for properties. Many of these, again, have the same labels because that's just the way the OTLs are, but some differ. for example, you have the manufacturer serial number that comes from Conco and has the same meaning as serial number I'm looking for. Oh, here it is. So same meaning, different property name. These two should be bridged somehow. So when it comes to data, let's see what that looks like. I am looking for the project Conco to grid op CMDB. So this is the project database with the two different perspectives. And as I open it, we see right away that, for example, the building instance that we had before now has two types, one based on Conco and one based on grid op. Same for everything else that we've mapped. You see capacitor systems, you see doors, buildings again, everything that was mapped in the class crosswalk. Let me select the door again, because that's the simplest thing we have probably. And it looks more or less the same as before, but now I have the option to select something else in this dropdown that did not exist before. I am going to open a separate panel here so we can see the two perspectives side by side. And I'm going to select door with lowercase d for the second one. And this is what pops up. So you see the item ID has been transferred to the grid op perspective as well, together with the serial number and some other properties that we mapped. We have not mapped everything to make the point, but we see the fire protection rating, for example, the function, and the year of construction. And another neat detail to note is that some properties have this little red asterisk next to them. And what that signifies is that these properties for this OTL are mandatory. And why do we have asterisks on one side for item ID but not on the other, and for the serial number? Well, that's because different OTLs can have different requirements. So I, as a contractor, absolutely need my instances to have an item ID. I cannot do without that. But evidently here, the grid operator can. It's not so important to them. So this is how this goes. We have seen how we have data and a database that is based on the OTL of the contractor. And we have created crosswalks to bridge classes and properties between the contractor's OTL and the customer's OTL. And since we have done this, we can now observe what different things look like for each of us. Let's also look at the cable. Same story if I switch to the other perspective. Connections, functions with different requirements for the two OTLs, and everything appears on the second perspective as well. And with this, I would like to conclude this part of the demo and hand it over to David to tell you more about graph coalescence and inspection data.
Thanks, Ileana. So what I'm going to talk about now is a small demonstration. I'm going to show how business rules can be implemented in a knowledge graph. And this demo, as Ileana mentioned, these are based on the W3C shapes constraint languages. And in this demo, we have an existing physical asset database, the CMDB, and it's included by reference into an inspections database. The inspection schema is layered automatically over top of the physical asset schema, but I have added a reference from between them to the physical object class, which makes the physical objects themselves, the assets, possible subjects of an inspection. And then in that inspection schema, I've added a business logic to support producing new inspection data based on some existing inspection data. So I've kept the demo quite simple. I'm not trying to show any kind of best practices, and it's not optimized in any way. And the main aim is to show that the learning curve for getting started and creating business rules inside of KG is not that hard. Basically, in this little example, it's showing that anybody who understands the Shackle query language, the standard Shackle query language, can quickly get started implementing rules. The scenario here in this demo is we will generate an actual inspection with the status of planned based on the next inspection date property of an inspection plan having passed. The date is now in the past. The rule itself is linked to the inspection plan class, which is also defined as a Shackle node shape, which enables the Shackle rules to be attached to it. So you can see that the logic is quite simple. Let me go to the system. So here's the grid inspection schema. It has a inference rule, as you can see down at the bottom, which I've connected up to it, generate planned inspections. If you go and look at that, I've made a separate screen for that. You can see that it's a Sparkle construct rule. It's a rule based on the inspection plan, and the logic is that it goes out and looks for inspection plans that are complete, so they have a method and a subject and a next date, and then it compares the date of today with that next date, and then generates a new inspection, a new actual inspection with a status of planned. So let's go here. So there in this tab, I've got the current inspection plans. In the next one over, I've got actual inspections. I've just made a little simple one. So you can see, for example, now that this is supposed to happen on November the 1st. If I run the inferences engine behind the scenes, nothing happens. That's what we would want. So if I go in, however, and change so that this should have happened on September 26th, then if I run my business rules, I see that it has inferred some new data. And this is available as an API. A user does not have to implement this themselves or push the button themselves. It could also be put on a scheduled basis, so it ran every night, if that's what you preferred. So this little button here asserts the triples that I've just generated. So now if I go back over here and run the query on the database again, I will see an actual inspection that has been generated by my rule. The actual inspection just needs to point to the inspection plan, and then I need to add a date and a name of an inspector, which are things that the rules themselves can't derive. They can't decide which inspector is available, although if there was enough data in the database, that's possible. So this needs to be edited, and I'll do that now. So what I would do is I'll say it's going to happen on the 15th, and that Joe Blogs is going to do the work. So what I also should do is change so that I've made this little template. And used a little naming convention to set this. And these can also be automated under the covers if you want, but I'm just doing this manually myself. So the second thing I need to do is to go back, and now that I've got a planned inspection, I want to go back to and reset the next date to be 2022, so that I know that this rule doesn't fire again. So if I now run the inferences, I see that nothing happens, and I've got my inspections built. So as I mentioned, it's just a very simple Sparkle rule-based business rule. However, as rule developers become more familiar with the technology, they can find very useful and more advanced features, for example, to reuse some components of a rule. They can also follow better practices than I did in this demo. Here, I actually defined this rule directly in the schema, as you recall. The structure schema, best practices, you might make a separate graph to contain the business rules because they may evolve over time at a different pace, and they may also be, it may also be the case that you want to use different business rules in different scenarios. And also note that all in this simple case, this thing only generated a single instance. It's also quite possible to generate a network of instances with a single rule, and then actually those instances could cause the inference of further data based on what was generated. And then just as a final note, as Ileana said, this technology of generating rules is also capable of generating schema because the schemas in a knowledge graph are actually data. Of course, those are slightly more technical level rules, but it's the same technology. And that's how the grid code view that was shown earlier in the demo for this in the webinar was created. So that's the end of my little part of the demo. So I'll turn back over to Jan to wrap things up.
Thank you, David. So, well, let me wrap up the basic takeaways and key points. Well, of course, technology is very important, but the most important thing is that as a construction company, you can follow a standardized work process from project to project to project, so that people know what to do, that cost is predictable, and so on and so on. Well, what we have here, what we have shown today, is a standardized work process that's based on mappings between knowledge graphs, and that makes sure that data integration across projects is greatly enhanced. It's a lot simpler than in the classical approach. Now, knowledge graphs are very important in this whole story because knowledge graphs uniquely express data and data models in a unified way, and that's really the secret sauce that makes all this happening. So that was basically our message for today. We're coming at the end of the presentation. So with this, the floor is open for questions.
Thank you, Jan. And if you haven't already, please do submit your questions and or discussion points in the question box located on the right-hand side control panel. We'll go ahead and get started with a few of these questions. First question, what happens if the customer's OTL gets updated? Do I need to start from scratch? Eliana, maybe you can take that one.
All right, I'll take this one. So the answer is no, you don't have to start from scratch. Let me see if I can share my screen actually, because there are two ways to tackle this.
I'll give it to you. Eliana, go ahead.
Great, thank you, Christy. So if you have one crosswalk, you can go into it and create a copy of it for the new version. You go into this tab that says manage and create a cloned version. And then you can go ahead and point that cloned version to the updated version of the customer's OTL. I am not going to do it right now because I don't have another OTL at hand on my workspace. But you can, in that case, go ahead and generate mappings again to get suggestions for the updated classes or properties and select whatever you need. And the second way to tackle this is by exporting a mapping you've already created and then re-importing it into a newly created crosswalk. So crosswalks are essentially stored as triples, of course, with the structure of thing A matches to thing B. And Edge can read those triples back in, and if you want, you can even modify the triples that you import to have the new mappings ready to go every time. But exporting what you already have, modifying it to satisfy your requirements for the new matches, and reading it back in is definitely an option. By no means do you have to start from scratch. You can reuse what you've already got and build on top of it. I hope that answers the question.
Thank you, Eliana. Jan, I'm going to toss it back over to you for the slide deck, if you don't mind reposting
Sure.
that. Okay, let's go to the next question. Let's see, you mentioned some standards in the construction asset management area. Are there more such standards existing or in development? Jan?
Yeah, sure. I'll take that. Well, I mentioned CBNL as a Dutch national standard. I also mentioned CFAS as an international standard. Both contain thousands and thousands of physical objects of different types. Well, there's a whole slew of standardization efforts that's going on, both on national levels and internationally. Well, I can mention some of them. ICDD is an ISO standard for exchanging building data. There is SEN TC 442, which is a semantic modeling standard for the construction world. There's the BOT, the building topology ontology. There is the SAREF family of standards that's coming up very strongly. So yes, there are many standards around, and of course, the nice thing about standards is that you have so many of them to choose from. But I think it's a very telling phenomenon that so many RDF-based standards are hitting the market right now. I think it shows that there's a real need for interoperability and also a growing awareness that knowledge graph technology, RDF, is the key to this problem.
Thank you, Jan. And I think this next question is also for you, Jan. Is it possible, and has it to be avoided, to have a 1-to-n mapping between classes of the two ontologies?
Oh, that's a very good question. Well, hopefully you have one-to-one mappings, because if you have one-to-many or many-to-many relations, that's going to be really hairy. So when you have to, then you would have to factor out the commonalities. So what I'm saying is, in those cases, what you probably do is you create subclasses that are specific for that project. And it can always happen that the ontology that you're using, the OTL that you're using, needs more detail. So it's never cast in concrete. An OTL is always growing. There's always a new version of the OTL coming up. And so if you find that for a certain project you need more subclasses of some class or more distinctions, then that's one option I would recommend. Otherwise, well, mapping is of course a very complex topic. We've not tried to make it seem easy. In many cases it is easy, but there are also some more complex cases. So for instance, when you have one OTL in which we use QDT, Eliana mentioned QDT, in which you have a more complex representation of quantities. So for instance, you don't say that the length is 130. No, you say the length is 130 expressed in meters and not in feet. So when one party uses simple properties and the other uses QDT style of representation, then you need to bridge that. And what I was saying at the beginning is that for the complex cases, once you have the patterns mapped, those more complex patterns, then you can reuse them for other projects too. So once you've done that, any case where you have a simple property mapped to a QDT property, that will work automatically, the mapping at least. So to summarize, if you have many-to-many mappings, what you usually do is try to create more finer-grained classes, and more in general. Of course, mapping can be a complex thing to do, and well, there's a ton of literature on that. Actually, there's a whole literature on ontology alignment, and most recently there's this book by Juan Sequeira and Aurela Silla about designing and building enterprise knowledge graphs. It's a very good source for this type of question. So there's a lot of design patterns to approach all these complexities.
Great. Thank you so much, Jan. Looks like we have another question. Maybe, Eliana, maybe you could take this one. Is it possible to connect or map more than 2 OTLs?
Right, I can take this one. And again, if you can please give me screen sharing privileges.
Sure. Sorry, there you go.
Right, so in this case, the instances were generated via Edge, so manually. Let me close some unnecessary tabs. Right, so you have this interface on the data graphs, and you have this button that says new. If you click it, you're prompted to a screen that lets you create new instances of things. I can create one, for example. I want to create another door. Why not? Punch in an item ID and some serial number. And then you have your new instance, and you can attach any kind of properties to it that you want. So for this demo, that's how we did this. Of course, you can tell Edge to read in any RDF graph, and if it has also the OTL behind it, it is going to display it much in the same way as this screen was generated. So you can also do that. Let me know if that's a good enough answer.
Okay. I just switch the slides back to you, Jan. Thank you, Eliana, for that. I think with that, we'll go ahead and wrap up today's webinar. There are a few questions that we were not able to get to, but I think it'll be best for us to provide those in the form of an email response to the attendees today. Thank you, everyone, for your attention and your interest, and thank you to Eliana, Jan, and David for a great topic today. I hope everyone has a wonderful day. Thank you.